Namaskar, my dear friends. Let us talk about a switching regulator that can be used for our FPGA solution design, FPGA power supply. So these days, FPGA design is becoming quite popular with like switching regulators. And the thing is, we are looking for some power supply designs which can make our life quite easier. In that case, this is one of the IC which we have used in various applications for our FPGAs. Like we have AMD FPGA, we have Intel FPGA. So in AMD we have Spartan series, Kintex, and like Vertex. Similar to that we have Intel. In that we have Era series. Okay. So in those things we have tried utilizing this particular switching regulators. The benefit of this particular switching regulator is it has integrated inductor. So this challenge is going to be mitigated in our design, right? So what happens is whenever we select any IC to design our power supply, there is a big challenge of selecting the like inductor. In that case, the inductor becomes quite challenging. All right. So what we will do is we'll try to understand this. So first let us get into the product page of this particular switching regulator, and then we will see the details of this particular data sheet. All right. And as you can see very quickly, the application of this particular switching regulator is like server systems. We have medical and imaging equipments as well. Like you have like ultrasound or CT scan, MRI, all those devices. They require FPGAs. In that case, you can utilize this particular switching regulator. This can give you various outputs, like let us say a 5 volt 3 ampere or 3.3 volt 3 ampere. All the way down you can go up to 1 volt 3 ampere. Okay, so it is very much suitable for your FPGAs, ASICs or DSPs. The places where you have like very high density board and you don't have a space, there is a space constraint, basically very small size solution you have to design. In those cases as well, this particular uh, switching regulator can be utilized. Okay. All right, so let us get into the product page of MSP MPS. So basically this is monolithic power system. So as you can see, this is 18 volt input 3 ampere module synchronous post CCM, that is current control mode or continuous current mode, step down converter with integrated inductor. So inductor is integrated. Hence the like circuit becomes quite easy, very simple. All right. And a lot of benefits are there that you can see. We have like complete switching mode power supply, 3 megahertz switching frequency. We have very wide input like 4 volt to 18 volt input is there, and it can be adjusted from 0.8 volt, not 1 volt. It can be 0.8 volt as well. Okay. It has internal soft start, so you don't have to struggle with choosing a capacitor to make a soft start. Then it can give you 3 ampere continuous current output. All right. Similar to that, we have power good indicator also. When the output is within the range, it will be high, or when it is outside the range, it will become low. It has overcurrent protection, over voltage protection, thermal shutdown, and all those things are there. And the size is very, very small, which is just 3 mm cross 5 mm. It means inside inductor is inside and still it is very small size. All right. If you want to quickly evaluate this particular product, you can buy this particular evaluation board and it can give you the solutions. As you come down here, we have lot of resources, as you can see. So in these resources, you are able to see that we have Versal, or like we have AMD. I mean, basically they are going to give you lot of solutions for like different designs. So if you want, you can go ahead with some of the reference design for Versal Premium FPGAs. Okay. Or we have Xilinx reference design. Lot of reference design they have already like made it. So you can see this is the way power supply requirement will be required, and in that case you can utilize this particular MPM 3632 series. So one of the IC, this one 1.5 volt 1.2 ampere has been utilized for 1.5 volt power supply. Okay. Anyway, we will talk about like power supply sequencing and all those things in later. However, our main aim is to understand this particular situation. Okay. So coming back to the application of this IC, so what you can do is lot of Spartan 7 ICs are there which we have utilized, like uh, Spartan 7, or like we have Kintex, Vertex, or similar to that, you can utilize in Jinx 7000 series as well. So Jinx 7000 we have used lot of them. Similar to that, if you want Stratix ICs as well as like Era series and all, you can use them. All right. So with this, what we will do is we'll just go ahead with reference materials and all. You can always find out, not a problem. You have the evaluation board, and you have like calculation sheet, and basically design parameters, design methodology, and all those things. Okay. All right. So let's get into the MPS datasheet. So as you can see very nicely, all the features we have already explained you, so not a problem. Let's get into the typical application circuit. So typical application circuit, if you see, we have an input voltage, let us say 12 volt. We have one enable signal. If you want, you can directly pin it to this, and so that you don't have to like switch on or switch off. If you want always like permanently give you the output, you can connect it directly. Okay. Then this is the input capacitor. We will try to make it little bit higher size because we want to have proper understanding. Then we have BST pin where it is internally connected, so you don't have to like add external capacitor. This is a switching output. This also you don't have to connect externally any inductor and all, because inductor is integrated. This is the output pin. So output pin is going to give you like your output requirement or output voltage, and this is the feedback voltage setting. So this is the resistor divider that will be utilized to make your or regulate your output to the desired level, and this is the output capacitance that will be needed. There is a out sense pin which will require one like a 1 kilo ohm of resistance connected to this. If you want in the switching, you can add an extra like snubber circuit, like one resistor and plus one capacitor. The values I'll tell you later on, and this way you can like mitigate some of the noises, and this will improve your EMI/EMC performance. Okay. And this is the PG, like power good, and this is actually one LDO, linear regulator output, so this can be also used for some small applications. Okay. As you can see the efficiency curve, so the out like efficiency is going well above 90% for input of 5 volt. For 3.3 volt application, if input is 5 volt, your output is going quite so output efficiency is very high. Okay. As your input is going to be increasing like 12 volt or 18 volt, you can see a little bit reduction in there in the like performance, but it is still well above 85%. Okay. So this is the part number that you can directly order. Coming back to the package reference, so package is made in such a fashion that it has very good heat dissipation capabilities and all those things. And you can see we have switching pin with good power pad and all. We have output pin with like good pad. Then switching pins are more. Okay. Then we have power ground, and we have analog ground. So analog ground and power ground both has to be actually sorted. This is the V input pin well above, and we have feedback connector here, we have enable pin here. If you want, you can keep vias well within like well below this particular IC, so that you have proper heat dissipation. Let us get into the absolute maximum. So we have absolute maximum rating already. We know like this will be what is the range of V input or SW or all those things that is there. So that's not a problem. The junction temperature can reach as high as 150 degrees centigrades, that you can see. Okay. So it can work up to 150 degrees centigrade. Thermal resistance is quite good. You can see we have theta J just 46 degrees centigrade per watt. So for 1 watt of power dissipation across this, you will be having 46 centigrade of increase in the temperature. All right, so let us get into the pin description and all those things. So before that, few points you have to like keep in your mind before while designing the circuit. Okay, so what will you do is, let's get into the switching frequency. So switching frequency typically it is 3000 microhertz megahertz sorry, 3000 kilohertz or 3 megahertz. Then over voltage protection, you can see it is 115%. Okay. let's say you have 5 volt input, so in that case you will be having 15 that is 5.75 volt over voltage protection. Okay, that is 115%. You can see power good. So power good basically it is around 115%. So it will be good whenever it is ever around 90%. Okay, and it will become fault when it becomes 80%. So 80% output, it will give you a fault condition. Coming back to the performance characteristic is fine. We know already. Let's get into the pin description. So as you can see, we have 4 pins of PG&D. So basically what you have to do is you have to give it a reference ground, and you have to consider a special consideration for PCB layout. Basically you have to connect a very wide, like a plane for PG&D. Okay. And you have to connect this PG&D to your ground with copper vias and traces also. So like let's say you have the ground, like plane or something like that. There you have to connect this PG&D properly with copper traces. Bootstrap capacitor, you don't need external connection. You just have to leave it. Switch output, you have to also, if you want, you can leave it as it is. Just sort all these switch outputs together and keep it connected. Otherwise, you can always connect one snubber circuit as I mentioned. Output is power output that is going to have. Then out sense, it is going to give you, like a proper terminal of the output. So if you want, it is recommended that you connect this out sense to your out pin through a 1 kilo ohm resistor. Okay, or directly also you can connect, not a problem, but giving 1 kilo ohm is better. This is enable high pin, as we have already mentioned. We have power good pin. Then we have feedback design that we already know based on the like design equation and all. But you don't have to use this design equation at all, because there are a lot of circuits that is already given in the typical application. This is the analog ground. So analog ground, if you want, you can connect it to PG&D itself. Now this is a VCC. So VCC will not require any decoupling capacitor. That's the beauty. Okay, so you have already like a decoupling capacitor integrated in the IC. So there is no need of any external connection or external decoupling capacitor and all. And that is used for your internal, like a regulator purpose. And this is your input supply that has to be connected to the input power supply with a like proper decoupling capacitor and input capacitor. All right, so this is all about this particular, like switching regulator IC, and we can see that it has internally, like internal regulator is there, bootstrap capacitor is there, we have switching pin here, and we have power ground. Okay, then we have input, like input pin here. We have one capacitor integrated. However, output outside capacitor is needed. Okay, then we have enable pin which is going through your like error amplifier, and this is how it is going to make sure that output comes on like whenever input is given and whenever you require it. Then this is a feedback circuit which is going to go again with like error amplifier to compare the output, and it will regulate that. Good, so this was all about this. Coming back to the operations and all, so that is fine. We have PWM operation, we have already seen. Soft start was internal. Yeah, this is what I was talking about. So additional RC snubber circuit, if you want, you can connect it to the SW pin with 5.6 ohm resistance and 330 picofarad. You make sure that the capacitor is not very high. If you want, you can go ahead with a little bit lower as well, like 220 picofarad or even 150 picofarad. Okay, but this is the recommended value, so you can go ahead with this as well. However, make sure that with this snubber circuit, you are going to have this much power loss. So your capacitor CS goes as low as possible. Your power loss also goes down. Okay. So you just make sure, because Fs is already 3 megahertz, that is 3000 kilohertz, and input becomes little bit higher. In that case, power loss also becomes higher. So my input is lower, my power loss is lower. My CS is lower, my power loss is lower. So only these two options we have, other than like a Fs. All right, so let us get into the next page. Yeah, this is what I was talking about. So we have a feedback pin where we have R1 and R2 to set your V output regulated, right? So to set these particular things, we have to connect R1 and R2 in such a fashion that it will require a like a your regulated output voltage, like a 5 volt or 3.3 volt, or let's say 1 volt, even 1.2 volt or 1.5 volt, 1.8 volt. So all these voltages are actually needed for like power supply of FPGAs. Okay, even 2.5 volt and all. So this particular equation you can utilize to find out that particular like values like R1 and R2. However, the best part is, for any output they have already suggested resistance values and calculations, so you can directly utilize them. So for 5 volt you can connect 47 and 8.87 kilo ohm. Similar to that, for 3.3 you can connect directly 47 and 15 kilo ohm. Okay, and coming back to the other parts, we have other voltage like 2.5 volt or even 1.8 volt, 1.5 volt, 1.2 volt and 1 volt, right? So they have already calculated the resistance division and all, so you can use these values directly. So you can come to page number 17 to find out those values for every like a voltage regulation output, and you can connect them. That's all. So this was all about this particular thing. If you wish to, you can read this particular PCB design guideline. Basically, you have to keep input ground and like ground as short as possible and wide as possible. So you have to give a very thick pad. Okay, so that's the thing you have to understand. Then basically you ensure that all the feedback connections are short and direct. So basically the voltage divider feedback resistor has to be very very short, like it has to be very close to the IC pin. Okay, this is what is given here as well. Then we have root sensitive analog areas such as FB away from the switching. So this switching pin has to be little bit away from this FB pin. Okay, and you have to give enough bias around chip for better thermal performance. That's the reason I told you, like, proper bias should be given. Good. So this was all about this IC. Let's get into the typical applications. So one of the application first we'll discuss, and then we'll see what is there. So you have V input 6 voltage. Let's say we have an input of like let us say 12 volt, and we have to get 5 volt output. Okay, 3 ampere. So in that case, let us say we have 12 volt here. You can directly connect this input here itself. That is connected through 100 kilo ohm resistance. Okay, this one is not used, so let it be as it is. Okay. Now coming back to the input capacitors. Input capacitor, as I have already mentioned, what you can do is you can connect here, let us say 100 microfarad, one more extra. Okay. So polymer capacitor you can use. Then 10 microfarad, if you want, you can add one more, like 22 microfarad. 0.1 microfarad is not needed because it is already there inside inbuilt. So if you want, you can add external, like one more 0.1 microfarad as well. Or a series of like 3 4.1 microfarad. I will give you the circuit when I give you the application circuit. That time I will give you exact circuit what is needed. However, the suggestion is add this much. Coming back to the output capacitor, same way, if you want, you can, like add external, let's say 330 microfarad for, like a better output and all. So you can add polymer capacitor with 330 microfarad. Please do not use any electrolytic capacitor and all, because we do not want to increase the board size and all those things. Ceramic capacitor, or we have polymer capacitor, that is good. Coming back to the feedback design, so feedback design, they have already given 47 kilo ohm and 8.87 kilo ohm. So you can use these two values to get your 5 volt output. Coming back to switching pins, so you can sort all of them and connect 6 ohm plus let's say 330 picofarad here, and give this provision so that it will be better. BST pin, you can leave it open, no problem, there is nothing required here. Outsense pin will be connected with 1 kilo ohm resistor, and this is how it will be giving you the output. Coming back to the VCC pin, so VCC pin, they have given a provision for external capacitor as well. However, in the datasheet they had mentioned that internally it is there. So if you too wish to, you can connect external capacitor of, let's say like a 4.7 microfarad, you can connect. Now let us get into the PG pin. So PG pin, what is going to happen is, since this is the LDO or regulator output, so this can be pulled out to this particular point with 100 kilo ohm, and this can be used to drive some MOSFET and some LEDs. So what you can do is, let us say there is a MOSFET that is there here like that. Let us say here 5 volt will connect here, and then this is my LED. This is, let's say 470 ohm. So what you can do is, you can connect this pin to my PG pin, and in that case what will happen is, since this PG is always high, so this will be high and the LED will be glowing. It means it will be indicating that your output is there proper. Now let us say there is a fault in the output. So what will happen is, this PG pin will go low, and in that case MOSFET will not be working, and in that case this LED will go off. So alright guys, this was all about this particular switching regulator design. So we have designed 12 volt to 5 volt output with 3 ampere. So I'll give you the circuit design with proper input output connector and everything, and with bill of material as well, for two solutions or three solutions. Will give you, like, one will be 5 volt 3 ampere, then 3.3 volt 3 ampere, and 1.2 volt 3 ampere. Okay, so these are the three things we will give you. Even instead of 1.2 volt, will give you 1 volt, because 1 volt is very much used in as a core voltage in your SPARTAN FPGAs. Okay. Similar to that, if you want, you can refer some other voltage range as well, like 3.3 volts. So basic changes will be seen as feedback resistance changes, and other than that you don't see any other change. Okay. Similar to that, for 2.5 volt, again feedback resistor divider change only is there. Coming back to 1.8 volt output, again you will see the same feedback voltage change. And similar to that, in the first design, what I suggested for the output capacitor and input capacitor, so these things you can always keep in mind. Okay, and for EMI/MC purpose, you can reach out to us. We will suggest you how to connect inductors and ferrite bead and several series of capacitor to mitigate or to avoid EMI/MC issues. So that thing is separate topic. Coming back to the other parts, like 1.5 volt is there, so you can see all same thing, feedback resistance is changed here. Similar to that, 1.2 volt here, and we have 1 volt. Okay, so this was all about this particular thing. We have not used for negative voltage range, so negative I'm not explaining right now. Yeah, this was all about, I was telling you, like EMI/MC test circuit. So you have the input voltage here, and you can see you have a series of 0.1 microfarad capacitors. Then we have 10 microfarad capacitors, again 0.1 microfarad capacitor with ferrite bead, and then we have inductor as well, and then we have bulk capacitors also. Okay, So with this we can add like little bit higher capacitors also, so that higher capacitor can be added at this place. Okay, so this place you can add, let us say 100 microfarad or something you can add. That's all. So this was all about this. This has EVM board and everything as well. So what you can do is you can always go to the EVM board. So this is the like evaluation board, and you can find out proper like layout, schematics and everything, and you can download this circuit for your design. So please reach out to us for the design purpose of FPGA power supply, and anyway we have given you lot of different circuits and lot of applications using the uh, lot of analog devices circuits as analog devices ICs as well for getting the multiple outputs. Okay, so this was MPS solution, like monolithic power solution for 3 ampere output. We will be giving you in next sessions how we can design having proper power sequencing for my FPGA power supply designs, like 3.3 volt and 1 volt and 1.8 volt. So 3 4 power supplies will be required, and in a proper sequence fashion. So that also we will give you from monolithic power systems next. Thank you.